Hi everybody, I'm Benjamin Lamy working for Eiffage CLEMESSY, which is a system integrator specialized in industrial processes and buildings. During the previous conference, we had the opportunity to introduce some key projects we done with Dewesoft in the field of control benches for space launchers or structure health monitoring of bridges. I am pleased to be here with you to introduce one of our latest innovations in the field of control command software, a fully industrial web solution which unify the supervision and the energies monitoring. The climate challenge is one of the most severe global and systemic phenomena that our modern societies have ever had to face. It affects us all. Public authorities are committed to the official targets of 40 fewer carbon emissions in France by the year 2030 and achieving carbon neutrality by 2050. In short, we need to quickly turn low-carbon solutions that are still in the pioneering phase into standard options. And so, what can we do as software and system integrator for the industry? Applied to the industry area and more globally to industrial buildings, several functions can be centralized, controlled, and optimized in view to reduce our carbon footprint. The sketch displayed highlights the main industrial areas. So, what can be expected from the software in charge of the supervision and control of the buildings? In the air quality and air conditioning, calendar and meteo-based temperature management in the office, data acquisition of the atmospheric pollution. For the data center, it is also a matter of power consumption analysis and, for sure, temperature management issue. Let's focus a bit on the software itself. The supervisory control and data acquisition, so-called Scada. As a minimum, the facilities have to be controlled and commanded. The aim is to switch on and off the lights, the heaters, or the steam generators. One important thing is to have a capacity to interface with a huge quantity of protocols. To do that, we made the choice to build our software around the OPC-UA architecture. This is a good basis to interface modern equipment, but it is also a good way to develop specific drivers to communicate with more previous protocols we can encounter in the industry. If we look a little bit further, the operator must have the capacity to easily drag and drop the sequence to drive the facility. The CLEMESSY sequencers are available to do this. Lastly, several customers agree to deploy the Internet of Things to directly acquire the data and even drive some facilities. This is a major change for years to come. We can sometimes even avoid the programmable logical controller level and integrates the function either in the IoT or in the software server. Lastly, even if some of the previous functions with automatic sequence can lead to energy savings, one important thing is the energies management module. This module is scalable in the sense that we add constantly new functions required by the customers. We start with consumption follow-up, we continue with historic viewer, statistic and curve plotter, contract management according to provider's condition, and we are beginning right now the power consumption prediction thanks to artificial intelligence. All the features are integrated in Syclone by CLEMESSY software. Syclone is a software toolbox which is divided into two worlds, the real-time deterministic host on dedicated controller and the supervision, the Scada world, that can be hosted on edge or on cloud computing. The Syclone supervision is now totally hosted on web server technology. You have nothing to install on your laptop. You even do not need specific hardware to use it. This is a simple web link. We made this choice also to facilitate the maintenance cycle with our end customer. For instance, we deployed this Scada software this summer in Hungary without business trip required. All the supervision functions are available. In addition, you have the capacity to monitor the energy to act on your consumption. Lastly, the system is highly scalable. You will see some demos playing with a dozen of ins and outs, But you have also have an outlook of a project of 10,000 points for one site. In an hardware representation, Syclone ensures the interface with the operator, which requires a simple web browser. The design is responsive, so you can use it on your laptop, your mobile, or your tablet. The server is hosted on Edge, that can be a small PC or even a laptop. As software as a service solution, most of the time applications are on cloud. This can be the Eiffage CLEMESSY data centers, but for sure it can be yours. The interface with the process is performed via classical PLC or IoT, and data acquisition front-ends, the ones for Dewesoft, works perfectly well. The originality is that Dewesoft system is not only used as data acquisition, but also as third-party EtherCAT slave or via OPC-UA. So, speaking about OPC-UA capacity, let's turn to a small demo now. The use case is very simple. Dewesoft Paris equips mains power with Krafton. CLEMESSY set up a web server in Mulhouse. And let's go for remote energy monitoring via OPC-UA using Syclone Web. As you can see, I am on my office laptop. I'm just switching from Microsoft to Syclone Web Server connected to Dewesoft Paris, and just some clicks to access to the consumption of Loic steam. You have the voltage, amps, power, as well as accelerometer or temperature. We had basic cost calculation on electricity contract. This demo, which has been worked out in 1 hour, just gives you an example of remote communication using OPC-UA to distant site. So let's show now how to easily interface with sensors and actuators via Syclone on web browser. The use case was really appreciated by the R&D team. The aim is to acquire sensor and drive actuators to interface with the microfactory we made with Lego. So, a Lego-built microfactory is equipped with sensor. Inputs and outputs are interfaced via Dewesoft hardware, and process is controlled and monitored by web interface. Sensors are set up in several locations for speed, color, and temperature or voltage, whereas actuators are also spread on the pathway. The process is shown on the animated view. You get all the sensors and actuators. You can execute the web page on your tablet. The control command functions are executed in the web server. This small demo highlights the simplicity to interface to a process to acquire the data and to act on energy monitoring. But this is very small. How scalable this system is? According to this, I would like to turn to a significant project carried out in the frame of automotive, the supervision and energy monitoring of one of the top 10 worldwide car manufacturers. The project concerns more than 20 sites worldwide. In the main factories, the site to supervise and monitor is superior to 30 buildings. This represents more than 10,000 inputs and outputs to interface. The basic functions of the Scada are implemented. There are no specific hardware, no specific software configuration for the Scada system. Besides the full web software, the key point is the implementation of the energy consumption module. This is the view of one big industrial site of car manufacturing. The perimeter to monitor is inside the yellow lines. Here you have the main view of a site directly accessible via the web browser. To drive a building or an equipment, you just need to click on it to manually act. On this dashboard, you will find all the main functions available. The synoptics, to view and edit, the configurator, or how to add a new point, the sequence editor, which allows to trigger automatic action on overshoot, for instance, and the curves, which are very useful for energy report. On this last view, you get the typical curve required in energy monitoring. You display the contract management information according to provider's condition. Max power authorized is the green line, real-time consumption is in red, penalty days can be managed via rules where, for instance, you can avoid to start particularly less efficient facilities on some days. What is the gain for the end customer? Well, no official feedback is raised up, but one point is almost certain. When you start to measure physical phenomena, you can improve it of roughly 10%. So, this introduction on how to supervise and monitor the energy thanks to our Syclone by CLEMESSY software is now over. And my team and I will be pleased to answer to any question. Thank you for the attention.